Yo, what's up guys, I just built something super cool. A 3D printed portable Bluetooth speaker with a sleek futuristic design. It's modern, minimalist and completely unique. In this video, I'll take you through the design, build and testing process. So without further ado, let's jump right in. First things first, I fired up my Fusion 360 to design this speaker. I'm actually making it for my sister and she specifically wanted a white and grey color scheme to match her room's aesthetics. The design is ready, it's looking pretty clean and modern, so let's slice it and send it to my 3D printer. Speaking of 3D printing, if you don't have a printer but still needs custom parts, GLC PCB 3D printing service is a fantastic solution. Whether you are working on complex prototypes or custom parts, their wide range of materials and printing option ensures precision and high quality at an affordable price. They offer FDM, SLA, MGF, SLS nylon and even metal 3D printing with a ton of material choices to suit your project needs. I'll also be ordering a few parts for this project from their site. Just upload your CAD files, choose the material and place the order. Simple, right? Thanks to their fast shipping options, it only takes about a week for delivery. The print quality is impressive with clean and detailed finishes. These are also ready, so let's remove them from the build plate. The prints are done and they turned out super clean. So now it's time to put everything together. The assembly is pretty straightforward, just align the pieces and slide them together like a puzzle. And just like that, the main structure is ready. It looks pretty cool. Now it's time to work on the front and back panels. I'm using a 5mm Creel acrylic sheet. Unfortunately, I don't have a CO2 laser, so I have to cut it manually using a wood trimmer or saw. To ensure precise cutouts, I designed a custom 3D printed jig. This jig will guide the trimmer, helping me achieve clean and accurate cuts. The print came out perfectly. Now just align it and slide it in place to complete the jig. Looks cool. Not sure if it will be helpful or end up ruining everything. Anyway, let's temporarily attach it to the acrylic and make the cutout using the wood trimmer. Alright guys, as you can see, it did the job perfectly. I also used the same jig to make the back panel. This will go on the front, but we need some foam or rubber padding to make the enclosure airtight. So I got this 1mm foam sheet from Amazon. I used my laser engraver to cut it. It's turned out great, so let's install it and finish the enclosure. Alright, the enclosure is final. To be honest, it looks pretty cool. I really like the way it turned out. Now it's time for the hardware part, but before that, I wanna give a shout out to Altium 365 for sponsoring this video. The ultimate cloud-based platform for PCB design collaboration. With real-time team collaboration, you can seamlessly share, review and edit your PCB designs from anywhere around the world. Whether you are working solo or with the team, Altium 365 ensures your design stays synced and accessible. Design the future with Altium 365 where your next great idea comes to life. And for students, check out Altium Student Lab. Get free access to Altium Designer and Altium 365 with your university email, collaborate with your friends, earn industry recognized certificates, and boost your career. Click the link in the description to get started. Coming back to the video, I chosen 3 inches Heavy M3 and full range driver for this build. These 15-watt drivers not only delivers great sound but also have a sleek design. However, their original color doesn't quite match with the setup, so I decided to paint the front and back part white. That looks much better. The white finish blends perfectly with the enclosure. Now it's time to install drivers onto the front acrylic panels. But we can't screw them directly as we need a proper structure to secure the screws. To solve this, I 3D printed these custom mounting rings. which will be fixed onto the front panel. Installation is super simple, just snap them into place and apply some super glue to ensure they stay secure. Now let's attach the front panel and install the drivers. Alright guys, the front side is done and it's already looking pretty awesome. Now it's time to work on the back panel. First we need a switch. I'm using this sleek toggle switch. Next we need an input socket for charging and power. To house everything perfectly, I 3D printed a custom enclosure. Now that we have all the parts ready, let's start with the assembly. Alright guys, the back panel is finally done and this is how it turned out. Before installing it onto the enclosure, we need to route all the wires through the bottom and then secure the panel. Now that the back panel is installed, it's time for the electronics. For the amplifier, I'm using this XYP 15W audio module. It's dual channel 15 plus 15W amp. Next up, we have 3S battery pack, which I built myself. It's actually pretty easy to make. I'll provide a wiring diagram or a video link in the description so that you can build too. Now let's get these components installed and complete the build. So finally guys, our project is officially complete. It turned out even better than I expected and I absolutely love the look of it. Let me know in the comments how it turns out. Let's play some music and check out the sound quality. First impressions, way better than expected. The vocals are crisp, the bass is punchy, and it's surprisingly loud too. If you wanna build this speaker yourself, I have uploaded 3D printable files on Curves3D. Check the link in the description. I hope you guys enjoyed this build. If you did, drop a like, leave a comment, and subscribe for more exciting projects. Thanks for watching, and I will see you in the next one. Until then, bye bye, take care.